Right. Now I'm going to share the screen with every one of you. Okay. Since I see some students still joining up the classes, so maybe I say my name again. I'm Raymond Fu. I'll be your lecturers in this course, Advanced Engineering Mathematics. So in the tutorial, there are no tutorial in this week, and there will be a number of tutorial around, and it will be taught by me or Albert Chen or Daisy Wong, and so on. Okay, so that is how it works. So the tutorial will be start on next week. Okay, so let's look at some of the informations, right? Now, I would like to share the TLP. Is everybody can see it clearly? Yes. Okay. Good. So this is our teaching and learning requirements. Okay. All this material.
So the tutorial will start next week, right? Not the third week.
The second week. I mean next week. The tutorial will start. Okay. Right. Now this is the teaching and learning requirements for this course. So you must pass the calculus before you join this class. Okay. So they all printed on the Moodle. So if anybody who cannot visualize it or understand it clearly, you can refer to the material that I already put on the Moodle about the TLP, and also there are a number of notes. This is the background of your study, okay, including the formula sheet and the formula sheet for derivative, okay. So I'll go over everyone with the details. Okay, so this is the requirement that you have to understand the engineering mathematics before you can apply on using other engineering problems. I mean, if you are solving engineering problems, if you want to make the mathematical models before you can actually work on some solution. Those are the theory, including the practice in these courses. Okay, so those are the course content. Okay, now refer to those content. Besides that, you notice that they are printed on the Moodle. You can also read through this teaching and learning program and understand the ideas. There are a number of ideas that you have to reasonable. For example, you have the analytical ability for solving some engineering problems, and also your solutions for how to make the abstract engineering problem into a one order, two order, or even higher order differential equations. Okay. And also you have to use some of the computer software. In this course, you will be learning something like the Mathematica or Woven Alpha software, so that it helps you to go through the solution of your calculus. And also you have to apply the engineering applications with using the suitable mathematical models, and then to manipulate or underline the differential equation models. Now, in this course, you have a number of requirements or assessments that that is including the workshops, okay, or tutorial. Now the workshops of this course will be something like the use of the software, for example, Mathematica, and then you know how to solve the problem by computer format. It can show you step-by-step calculations. And then the tutorial, of course, there are some standard questions that I would like to go through with you, or other tutors would like to go through with you in tutorial classes. And also there will be a little midterm test and also the final examinations. Okay, so those are the distribution of assignment, examination, and the quiz. Right. In this time of the day, I would like to ask if you have any ideas about the use of the quiz for this course, because you may have the choice of doing every assignments instead of a quiz. For example, assignment, we have 2 assignments, 1 quiz. Okay, because the quiz will be quite a big classes, and it will be done by in this time of the year, you may be done it by online. I don't know yet, because you have to understand the pandemic situation nowadays. So if the quiz, sometimes you may ask to come back face by face or online. It's still okay, but if you want, because there's still examination, formal written examination at the end of the course. So I would like to highlight that the assignment, there will be 2 assignments in this course and 1 quiz. Now I just like to take a vote from all of you whether you want to have additional assignment instead of a quiz in here. Okay, instead of the quiz. That means you have 2 assignments and another assignment here. Okay, so you don't need to have the quiz, and then left with the examination at the end of this course. Right, you can give me the feedback on the chat in this MS Teams, right? So I would like to ask for your consensus whether you want to change the quiz to another assignment. Since there are only 2 assignments in the first assessment method, and then I would like to ask if you have any ideas if I want to change the quiz to another assignment instead. Okay, just give me some feedback before the end of today's classes. Okay, now there are some informations to tell you that there's some exercise and also some textbooks which are good for you to do more practice in this advanced engineering mathematics. So try to buy or borrow each of those books from library or from the bookstore. Okay, of course we will give you some examples, but it won't be enough. The success in this course will be having more practice instead of just following the instruction by the lecturers, because at the end of the day you learn more when you practice more. Okay, so those are the reference materials on the teaching and learning outcomes. So including those lecturers and tutors who you may be contact in this course. That is me, Raymond, Daisy, Yvonne, and also there are another additional tutor for the tutorial group for EEM, that is Ever Chen. Maybe I put his name on this TLP later on to update the information for you. Okay, for the tutorial of EEM students, you have the tutorial classes on, if my memory is correct, will be on Thursday morning for EEM students. Okay, so let's look at some other informations. Now there are two additional notes regarding the formula. Those formula, like the one you see on the screen now, is the formula sheet. Now, this formula sheet will be more or less the same as you will be seeing in your final examinations. Okay, so the equation sheet is the things that you have to apply and use some mathematical model during your written exam. So equation sheet will be including, if you don't know what are they at the moment, it doesn't matter. Those are the name given for the equation, like except ODE. Okay, that is the ordinary differential equations, right? That is the mathematical models. And the other one will be the integrating factor. Okay, and so on. There are a number of equations that you need to learn and use them, at least to use them, or that means applying in your final examinations. Okay, there are a number of equations, including 5 pages. Okay, they are all listed on your Moodle, so please check it out by yourself. Right, those equations you were given, and you have to learn it in this course. Okay. Now that are the table of integration, and also those are the formula you learned it from your first course, the calculus 4201. Okay, so those are the integrated equations in details. I mean, in details, this is only the general equation. You know how to apply it. It's most important. If you have come across any questions, I would like to explain more in the tutorial classes. Okay, but before that, please study in more details. Okay, so those are the equations you normally use in this course. Yes, any question? Okay, no. Thank you. I continue. Now, that is another formula. Again, it's shown on the Moodle. Okay, you can find it out later in your Moodle. Now, this is the formula for derivative. Okay, just try to compare to you some of the equations, some of the. Oh, sorry. Okay. Can you hear the voice now? Yes. Sorry, I pressed the wrong button sometimes. Okay, so those are the equation for the derivative. Okay, and refer to some rules like the power rules, reciprocal form. When do the derivative, what will be come out at the end? So you compare the function when you do the derivative, and then the answer will be on the right hand side. And also, this is the standard format for our differential equations, right? So those are the names. If you can't recognize them, try to practice more. In your first course, there should be some exercise for you before, okay? But here, I just like to summarize up the basic calculus, derivative, and integration formula in one go. So by all means, make use of those equation or formula in this course. Okay, they are helpful. Right? Okay, so those are the information that I have to introduce to all of you about the basic formula you have to learn and to remember and to apply in this course. Okay. Other than that, do you have any questions? Now, I would like to see and take the attendance. Now, the attendance number is 127. Let me take the attendance first. For taking attendance, you don't need to do anything, okay? I just press the button on my screen, all right? Let me see if you have any questions. Okay. Right. Okay, I see some of the feedback from some of you. You like to change the quiz to another assignment. Okay. Any objection? Yeah. If no, that will be all of them taking assignments in your continuous assessments. That means 60% will be in 3 assignments. Okay. Good. Yeah, I see there's no objection. Right. Okay. So now, since we give you the introduction of the teaching and learning programs, and also the formula that you have to remember in your first course, that means your calculus course 4201. So this is course that give you the basic calculation and apply using the integration and derivative. Right. Let's continue to look at by having the first. Any question? No. Now, this is the PowerPoint for the courses, the first class. Okay, first class. Um, Let me press the button first. Okay. Can you see the screen? Can you see the screen? Okay. Right. You prefer the screen in this format or hang on? Or like this? Okay. Is all right? Okay. Now, this is the first lectures for advanced engineering mathematics. Now, for engineering problems, why we need the models or mathematical models. In doing so, we are trying to arrange some sort of calculations before we can actually solve the problems. So in any cases, if you have any engineering problem arise, we have to do the engineering applications, and so that we can do some physical solution problems and try to do the interpretation so that the normal layman, okay, the one who doesn't understand mathematics can also understand what you try to do, okay? So at the end, you generate some mathematical models so that you arrive with some mathematical solutions. Then in mathematics, the mathematical formula is something like the mathematical tools. It just helps you to solve problems or you handle some engineering problems. You need some sort of hammers, screwdrivers, something like that. Okay, so those are the tools help you to solve the problems. In the engineering world, you need the mathematical models to solve it. So you must to choose a right choice. Okay, the right choice. That means you have to apply the correct mathematical formula. Okay, in order you can learn how to use it. The very common one will be the ordinary differential equation. In short form is ODE, ordinary differential equation. In this kind of equation, it may contain one or several derivative functions, which are including an unknown functions, right? So this is an example, okay? The examples of y double dash and y dash stands for the derivative for one time, for the first time, and the derivative for the second time, okay? This is the y dash stands for dy over dx. Y double dash is dy the second time over dx squared, okay? So in the mathematical family tree, it's come out starting from the first order differential equation up to the end of the higher order and also other differential equation, including the partial differential equation as well. Okay, so there are different kind of mathematical differential equations from the family tree of DE. Okay, so now we firstly switch on to the first order differential equation. In the first order differential equation, we can distinguish it or separate them into two kinds. The first kind is explicit function and the other one is implicit functions. The way they distinguish them will be their functions having all the items inside, or it can just give you some variables. Give you some variables. Here is some examples. Okay, just like the y dash stands for dy over dx, with the equation on the right hand side where you have all the single variables. So the explicit function and the implicit functions, okay, you can separate into solutions. So the solution usually in the implicit form that will not be written in the explicit solution. For example, in this first case, we are asked to verify the function, whether this function is the explicit solution of the equation, right? So we have the ordinary differential equation as shown in here, the yellow in color. And the blue will be the question to ask you how you're going to justify as the explicit solution. Okay, you are trying to prove whether this is solution for the following equation in yellow color. Now, let's look at how it separates the two ideas. The first one is you have the equation first, and then you have the explicit solution. So you try to look at your equation, the yellow one, by having the derivative, okay? Why? Because this is a solution. So you just insert the equation so that you can find its derivative one by one, okay? Since the y equal to e to the exponential of 2x, okay? Then the y dash will be according to the exponential rule. The derivative of y will be take out the common factor of the index. So it becomes the 2e2x. Okay? So this is the basic formula. If it can refresh your memory, the differential equation of an exponential function is to take out the constant from the index. Okay? So the y dash is like this. And similarly, you have the derivative for the second time, dy over dx again, dy dash over dx, okay? So you call y double dash. So y double dash, you derivative function again you take out the constant 2. So 2 times 2 is 4. So y double dash is equal to this. So at the end, you have all factors. Try to insert all factors into your equation in yellow by having those answer come out, right? So you have end up with the equation like this. And then after you modify it, you find it's equal to 0. Okay, so that it proves that the relationships are having the consent that it is the explicit solution, because it proves that the end result will be 0. Okay, so that is the solutions. In that sense, that means the equation y equal to e to the power of 2x is something you call it explicit functions or explicit solutions for the equations, and you are asked to prove it is by doing or applying the differential equation once and twice. Okay, if you get up with something like this, whether you have the equation or equal to 0, then you prove that this is the explicit solution. Okay, so that is the explicit solutions, and you look at by the general solution against the particular solutions. Now with the constant, you know, constant is something like the numeric numbers without the variables. Okay, so it just try to balance the equations, so we call it constant. With the questions that the constant undetermined inside the differential equation will be called as a general solution. The patterns for general solution will be things like this. Okay, so you have the equation where y equal to 50 plus c to the exponential of a functions. So c will be something like the blue color here is the constant undetermined. That means you don't know what the value of the constant yet. Okay, so you come out with or maybe you try to find out the particular solutions. That means you're going to solve the value of this constant. In that way, you name it as the particular solution. That means once you find the c, the constant, you call it particular solution. Instead of remaining c, you call it general solution in here. Okay, so the particular solution will be things like this. Whenever you have the value of c equal to some constant value, okay， 一啲數學嘅數字去 instead of 一個 c 嘅話咧，咁我哋咧就會叫佢做一個 particular solution 啦，明唔明白？即係話 general solution 咧就會有個 constant c 喺度，即係 c 係一個名嘅啫，你可以叫佢做K 又得，你可以叫 B 又得，係冇 ？OK， 咁所以呢個係一個 constant undetermined 嘅，就稱之為 general solution。如果我哋呢個 constant 都揾埋個數值出嚟嘅話咧，我哋就稱之為 particular solution。嗱，咁喺呢度咧，即係我知道啲同學咧就可能 understand 嘅數學嘅話咧，就要用啲中文輔助嘅嚇。I understand some of you may need some Chinese explanation to understand mathematical formula because it has some difficulty for you to understand everything's who are mathematical terms or jargons, which sounds so strange to some of you. Okay, so there will be sometimes I use some Chinese explanations for some students. Is that okay? 即係有時咧會用翻啲中文嚟解釋翻俾同學，因為我哋都有啲同學啦，我都要照顧下佢哋嘅利益啊，咁啊解釋下少少用中文，冇問題啊嘛。Okay, so we carry on. In the first order differential equation, 中文我唔知點譯㗎，總之我係叫做first order 嘅 D differential equation， 我哋叫 ODE。因為我哋跟住落嚟咧就會講一啲 second order 同埋 third order 甚至係 high order 嘅，仲有啲 partial equation 嘅。咁所以個 differential equation 咧喺呢度咧我都要解釋俾同學聽啊。即係頭先我開始嘅時候咧就喺 Moodle 噶啦，我就擺咗喺度嘅一啲formula equation。呢啲係個 basic formula 或者 equation 咧，喺你以前嗰個calculus 嗰科4201 4201咁你係應該學過。咁驚你哋唔記得咧，就所以擺低晒咁多 equation 咧喺 Moodle 先，第一堂就擺咗喺嗰個Moodle 嘅呢一科嘅notes 裏邊。除咗個 TPL， 即係成呢科裏邊嘅要求咁頭先咧都通過咗啲同學啦如果冇 objection 嘅話咧，全部會轉晒做 assignment， 咁我就唔俾個 test 啦。咁另外最尾當然有個 final exam 啦講咗跟翻個比例。咁個 formula 嘅字咧就麻煩啲同學咧要明白佢認識下佢計多少少啦。學呢科咧就一定係計多啲數嘅，就冇其他嘅捷徑㗎啦。咁亦都有啲好處嘅，因為呢科裏邊咧有個 software 叫 Mathematica， 你可以咧用喺我哋學校嗰度咧喺 campus DI 青衣呢度咧就7樓咁就有個 software 叫 Mathematica， 你可以歡迎咧就去到咁上下咧個 course 嘅時候咧就翻嚟去7樓用7樓嘅電腦室咧有個 Mathematica software。OK， so for the initial value problem， now I come back。就呢度課文IVP for the initial conditions, we have to consider the situation. For example, the engineering problems, the waterfall problems, hydraulic, the setup of engineering practice. So there are always some starting value. The starting value in mathematical model, we call it initial value problem。IVP， 即係話喺呢度咧 ，IVP 咧就係話任何嘅數學公式咧開始嘅時候咧，譬如話俾咗個 general equation。For example, we have the general equation. We have to solve it, and we normally give out some starting value. Okay, so starting value is the initial value problem. So initial value problems, we have some value given for different solutions. For example, starting from y0, we have given y4. 4 means the x value when it's equal to 4. Then the whole equation will end up with the solution or answer equal to 6. And similarly for others. Okay, so you have all the value fitting the x, then your answer will come out with y. It's a normal understanding of the equation like this. So given the initial value, then you can solve the ordinary differential equation by having incrementally insert into your suitable ODE equation. For example, in here, the left-hand side, the y dash minus 2x equal to 4, and given the IVP, okay, the initial value problem for y with bracket where x equal to 0, then your answer for the y equal to 2. So this is the normal practice for giving you the initial value problem. Okay, so this is the IVP. This the left-hand side the equation against the IVP value given. Then the examples for this ODE with the initial value problems, you do it by simple integration to start with. Okay, so you integrate both sides with respect to dx. Then we know the relationship between, as I introduced at the beginning, the y dash is a symbol, stands for dy over dx. So by moving term, you can just see after moving term, the dx move to the left-hand side. since it's the denominator, move to the left-hand side will become the numerator. Okay, so that means y dash dx equal to dy. Okay, that is trying to explain why you have come out with the dy. Okay, on the left-hand side, you replace the this set of formula or writing. Okay, dx times y dash by dy. So you left with dy on the left-hand side. So after you replacing, integration of dy is very simple integration solutions where you come out with y and then left with a constant. The left-hand side left with constant, you put C1, and on the right-hand side, normal integration for the separate in your general formula. You integrate it one by one, okay? Integrate 2x, you divide it by n, so you end up with this, and then your index for the variable will become n plus 1, okay? So you have x squared in the index, all right? So integrate of 4 dx will be having the variable come out 4x. And then you have again another constant left on the right hand side for your differential equations. So all in all, you leave it as a so-called C2. And then after simplifications, you don't need to have C1 and C2 because it is only a constant value. So you just simply replacing C1, C2 by C. So after simplifications, you end up with the equation like this. So that is how you're going to, at the end, find out the equation y and put everything on the right-hand side with x variable. So it is not n yet because this is what we call the general solution. So the general solutions, you still have to apply for the IVP. Okay, so for applying the IVP, you just very simple. Once you got the general equation, you just insert the value of your IVP value. For example, x replaced by 0 and the y replaced by 2. So you have 2 here, you have x equals 0, so that means everything is 0. And then you end up with your constant c equal to 2. Now put back your value 2 into your general equation. Now it end up with a particular solution. So that is the difference between the general solution and particular solution. Okay. So is that clear to you? 同學有問題啊？嗱，睇下做呢個 example 嘅時候咧，就做一個好簡單嘅 integration 嘅啫。兩邊 both sides integrate together at the same time. Okay, and you have to understand this is something like the change of variable or whatever. Okay, so you end up with dy, and then you strictly integrate and left with some constant. After your simplification, this is the normal integration techniques, right? There's nothing special. So you end up with a equation with the constant c. So in this way, you have the equation left it with the variable y on the left-hand side and everything including x variable on the right-hand side, and your constant is unknown, then this is called general solution. 即係 general solution 就係呢個款啦。OK， 就 constant 未知嘅。咁跟住咧，我用個 IVP initial value problems, then we insert the suitable value into the equation of general solution. Then you end up to find out the constant equal to a certain value. And then you put back your constant into your equation. And that is what we call the particular solution. Okay. Any question for this simple example?
我想問咧，嗰個咧 formulas for derivatives 咧，
derivative 係
係咪淨係適用於 D 唔適用於 integration，derivative 唔適用於 integration 就嗰度，因為第一張紙咧係講呢樣嘢㗎。
係
因為一欄係 function，一係 derivative 嗰個
啊
紙，淨適用於 derivative 唔適用於 integration。integration 咪就係用 table of integration 嗰張㗎咋。
table of integration 嗰張咧嗱，其實即係用嘅時候咧嗱，而家你之前有冇接觸過 ODE 啊？冇啊嘛嚇。咁因為 ODE 裏邊咧有個 derivative 嘅 function 喺度，即係呢個咧等於 dy over dx 嚟嘅。咁你就要將呢一個 equation 首先咧就揾咗個 general solution set 先，就去到好似呢一個咁樣嘅。如果你唔揾到呢個先咧，你就唔能夠將呢啲零啊、二啊呢啲東西咧去揾佢個 c。咁所以咧，你做一個 integration 嘅話咧，或者點樣都好啦嚇。咁你可以其實數學咧有一種方式嘅，呢個其中一種方法。可能你講緊嘅係咪另外一啲方法就咁就 derivative 去揾翻個 y 出嚟？
唔係，其實我係揾唔翻咧。之前 table of integration 嗰度咧，
係
table of integration 嗰度咧應該有一條式會可以將呢個 dy 變成某一樣嘢。integration 好似 integrate dy 咁樣啦，變成某一樣嘢噶嘛。但係咧呢度咧係好似
我哋同一時間 integrate
就見唔到咯。
哦，咁嗱呢個即係只不過話俾你聽個 pattern 咧個方式就係一個 general solution 同埋一個 particular solution 嘅分別嘅啫。咁至於你過程裏邊點樣揾出一個 general solution 咧，喺數學嘅程式裏邊咧有好多種方法嘅。即係話遲啲，譬如話睇個 mathematical 嗰個 software 咧，你打個 equation 出嚟，佢有好多個 step by step 好清楚咁話俾你聽嘅同埋超過一種個方法去做。總之個問題咧就係話喺呢度嚟講咧，如果俾個 initial value 俾個咁嘅differential equation first order 嘅話咧，咁你做出嚟嘅時候，無論你點樣做嘅話咧，俾咗 given 呢個 equation 嘅話咧，你 end up 都會有一個 general solution。So long as 你攞到呢個 general solution 出嚟嘅 pattern 係一模一樣嘅話咧，就得㗎啦，好冇 ？OK，或者我哋繼續落去先啊。係。
因為我即係只先處理咯，我暫時處理咯。
好，OK，唔該晒，Thank you。So we go to the exponential functions. Now, exponential functions, we have the relationship which are different significantly in drawing. For example, your exponential growth, exponential decay. That means it grows up very fast at the later stage, or decays very tremendously low in a very short period of time. Normally, the horizontal one will be the talking about the time, and the vertical will be some kind of value. Just say something like the number of bacteria, something like that. Okay, so exponential growth and exponential decay is the exponential E. OK， 嗱呢個咧就係 exponential 嘅 growth 同埋 decay。咁佢哋通常咧就講緊咧兩個好快速嘅增長或者係減少。咁 exponential 嘅話咧個唔同嘅地方就係平時我哋好多時都係講 linear 係咪？即係講直線咁但係呢度嚟講咧，我哋就講得增加得好快。尤其是喺嗰個後期嘅時間咧，佢上升嘅時候咧好急速嘅，或者調翻轉咧後期嘅時間咧就降得好低嘅好似啲譬如舉例咁啲股票咁樣，或者我頭先講啲病毒咁樣升得好快或者減得好慢咁諸如此類咧。咁呢個同個時間有關係，同埋咧佢唔係直線嘅。咁我哋有好多時咧可以將啲圖咧 plot 成為一啲 exponential 嘅 function。咁呢個係 general 嘅現象嘅啫So for the exponential equations, we have the symbol E. So exponential is in general definition from the outside number is 1 plus 1 over 1 plus 1 over 1 times 2 and 1 over 1 times 2 times 3. And they are continuous until very end. in normal sense, the value of E will be equal to 2.718, so on. Okay, it's never ending, but it approached to 2.72, right? And so it comes out from the people who called John Napier in 1618, okay, to do the calculation itself and arrive with the value E with these figures. So this is the history and the information given when they take the limit of the n approach to infinity with the power of n, where the bracket is 1 plus 1 over n. Okay, so it is the limit of the value with the n opposed to infinity. It ends up some values. So long times ago. Okay, so you also have his Bernoulli equations. Okay, so here we have another set of equations for the first order differential equations. That is called the exponential function. So exponential function plus the ODE, the ordinary differential equation. So you have to notice that the differential equations, the dE over dx, okay, the exponential, it will be equal exactly the same as itself, okay. Of course, it except whenever you have the nx in the index, then the n will have the factors come out in before, right? Otherwise, only the derivative of the ex, it will become the ex itself. So the ex, again, is the same as original functions. So that means it's equal to y. So dy over dx, if it is exponential function, it will equal to the y function itself. So that means in general, we derive some sort of equation so that you understand the derivative how many times, no matter how many times, for the exponential function, it ends up with y only. Okay? So you have to remember y dash equal to 1, y double dash also equal to y. So y dash equal to y, y double dash equal to y, y triple dash also equal to y. Except we have the growth rate where we have kx or nx, right? Then in that case, the differential equation of the exponential functions will have the vector or the constant come out as a coefficient of the exponential. 咁喺個 exponential function 嘅時候咧，我哋 D 個 exponential function，如果佢係有 growth rate 嘅，或者有個 constant vector，好似 K 啊、N 啊喺呢度嘅話咧，咁我哋 differential 呢個 equation 咧就唔係等於翻個 y 嘅，咁我哋咧就要 take 翻嗰個 growth rate vector 出嚟，成為一個嗰個 y equation 嘅 coefficient。咁所以咧，我哋就將佢 so it come out differently. When we have the growth rate, we have the ky instead of just y. So y dash equal to ky, y double dash equal to k times ky. That means k square y. Okay. So 我哋有呢個係我 differential 嘅equation 睇到喺 exponential growth 又點樣，喺 exponential decay the difference between the growth and the decay will be the negative sign of the constant value on the index. So the decay value is minus kx. So you have end up more or less the same as the y dash equal to minus ky. So exponential function, radioactivity, exponential decay. Now this is the some kind of examples that talking about the radioactive substance which are having 0.5 gram. What is the amount of present at any later time? So that means they are having the decay value. Now physical information is showing the experiment at each instant how the radioactive substance decompose。咁呢個咧就講翻嗱喺現實嘅問題咧，一啲文字睇啦in the common sense for the exponential decay, given the problems like this, how are we going to use the mathematical models to change to do the something like calculus derivative so that we can find the solution at any one time。咁呢個咧就係我哋一般學嗰啲 calculus 啊，或者同學嘅時學 M1、M2 咧，其實都明白呢個道理嘅。個問題咧就有啲同學可能個basis 咧未學過或者少啲接觸呢個 derivative 或者係calculus 嘅話咧，咁你發覺咧呢啲 integration 啊同埋 differentiation 咧就會有一啲嘅困難去理解。咁呢度咧就一個例子咧，就係話，如果我哋假設一啲輻射嘅物質輻射嘅物質咧就譬如話好似啲X 光啊嗰啲咁嘅嘢啦或者係有啲碳合物啊咁樣，佢喺空氣裏邊咧做啲輻射出嚟嘅原子彈啊嗰啲咁嘅嘢啦咁我哋咧嗰啲 substance 咧會去隨住時間咧會流失咗個 radioactivity 嘅。咁流失幾多咧？咁佢有啲叫 Exponential Decay， 即係話佢一路時間越耐咧，佢流失嘅咧就慢慢去穩定㗎啦。開頭咧一流失嘅時候咧，可能咧就好快嘅，但係流極咧都流唔走晒所有嘅嘢，即係等於啲人咁，譬如話啲骨質疏鬆啊咁樣又係咁樣啦即係慢慢流失嗰個骨質素啊之類。好啦，咁啲類似咁嘅例子啦So similar case to the human beings where we lost the bone tissues. Okay, so they are trying to decay at certain times. So how are we going to transform it into mathematical models? So very positively, we understand the derivative of function like this exponential will be proportional to y. Okay, proportional to y. So say for decaying, we use the minus k as a constant. So k stands for the positive integers. Then dy over dx will be equal to minus ky according to previous solution. Okay. So radioactive, for example, in there we have the y0 equal to 0.5. So that is his initial value problem, having the initial values. Then we have the decaying value dy over dt, because x, obviously the exponential decay will be respective to time. So dy over dt is equal to minus ky. Okay, so not dy over dt, not dy over dx, but dy over dt, because we're respected to time. So we change x to t. Now we then integrate on both sides. Integrate on both sides. We have the similar set of situations where you have to having the same idea of the change of variables. Now the integrate of both sides, please notice that we are respective to dt. Then you have to simplifications of changing variable on the left hand side is dy, okay, because dt cancel with dt here. And then on the right hand side with respect to dt, then you integrate it, you become the epsilon value. Again, this is the basic formula for the integration. Integrate of the reciprocal of function variable y, then you become the natural log of y plus the constant. And then at the same time, on the right hand side, you have a constant, you integrate it, you become the minus kt plus another constant. Okay, so after you simplified it, you can then by moving term, so you have to understand the rule of index and the logarithm, where you move the terms, you have the exponential, and then on the right hand side it moves to become the index. So y equal to e to the power of the function on the right hand side. So again, because the constant C3, you can then simplify as e to the power of C3. So it becomes another constant to replace e to the power of C3. So you just simply call another constant, big constant C. So this becomes the general solution. Back to our same questions. Once you find the general solutions, you can then have your particular solution. Okay, so the general solution against a particular solution, where you are aimed at finding the solution of C. So in finding the solution C, then you have putting the value of zero in your constant T. And then you have the y equal to 0.5. Okay, so your constant becomes 0.5. So after you insert the constant 0.5, you end up with y. Now the c becomes 0.5 times the functions where you have e to the power of minus kt. So it becomes the particular solution. Now that is the answer. In this case, because the question asks you find the amount of radio substance present at any time. So anytime you insert the value of T, then you can find your particular solutions, right? So that is the way that constant and matching with our periodic example, you have to find the general solution. After you have the IVP, initial value problems, you insert the value and you can find the constant and it becomes the particular solution on the right hand side. In the radioactivity, the exponential decay, then this is the answer. With the diagram, of course, you can put it on the left hand side like this. So it indicates the change of the radioactive substance as the times go by. 嗱咁呢度咧就即係最後就睇到啦嚇。頭先我哋做嗰個咧就係亦都係一樣啦，同頭先我哋唔係 exponential function 嘅時候，一啲普通嘅 ordinary differential equation 嘅時候，我哋都係先揾咗個 general solution，裏面包括咗個 C。個 general solution 咧係點樣嘅咧？就係 y 等於乜乜乜乜 x， 就包括咗有個 C 喺度嘅。OK，and then 咧跟住因為有 initial value，咁我哋 insert 翻落去咧就揾到個 C， 揾到個 C 之後咧就成為咧我哋嘅所謂 particular solution 啦，即係 insert 翻個 C 嘅 value 落去。嗱冇呢個 initial value 咧，我揾唔到 particular solution， 就只能夠 left with 一個 general solution。揾 general solution 嘅時候咧，頭先睇到喺 differential equation 咧，我哋識用嗰個 integration 啦，你哋記翻嗰啲 differential equation 嘅嗰啲 rules 㗎啦，好嘛？好，而家係10:01，或者我哋 take 翻幾分鐘嘅 break，因為我都要做 administration， 即係話要 take 翻你嘅 attendance 嘅嚇。咁OK， 咁我哋暫停一陣間先嚇，一陣間再繼續。咁我休息大概8分鐘嚇，咁我 take 翻嘅 attendance 先。嗱咁attendance 咧，今日有135個同學啊。OK，attendance take 咗啦。好，等我飲少少水先。 Okay, we start again. Right.
關鍵問題嘅就係咧，
係
嗰個
點樣？
integration 咧，中係咪已經列出晒我哋成個課程咧裏面需要嘅所有 integration？因為咧，我喺之前有個 slide 咧係 係 first order DE 嗰度咧 example two 咧裏面咧係揾唔到揾唔到適合嘅 integration 咧去去用㗎，因為咧個 table integration 我係咪即係顯示？
係嗱咁樣，因為嗰個好簡單嘅啫嗱，嗰個 solution 咧，咁如果有時間咧，我哋喺個跳出嚟可以講，同埋咧你可以醫俾我，因為咧嗱嗰個 equation 咧，你睇到我做嘅時候咧係有個 change of variable 嘅做法嘅，即係話你睇唔睇到譬如話嗰個 y dash 乘 dx 咧係等於 dy 嗰個寫法，因為我哋。
example two 唔係 example three 啊，頭先講嗰度係。
咪係咯，你嘅 integration 啊兩個 part 啊嘛，兩邊都一齊 integrate 噶嘛，咁你兩邊做嘅時候，即係嗱，除非你做一個模式咧，其實你可以做咗之後咧，你影個相，咁然後咧你 email 俾我，咁我解釋俾你聽你嘅做法同我哋嗰個分別。我頭先都講啦總之你嘅做法咧，我就要求有一個 general solution。就有一個咧 particular solution，你能夠 come out 出嚟就得㗎啦。中間計嘅方法咧，其實真係好多種方法嘅。呢個咧就係你要知道嘅，因為見到咧第時你做嗰啲功課啊、tutorial 啊、或者 assignment 咧其實有好幾種方法做嘅，我都會喺堂上咧或者係做 tutorial 嘅時候咧解釋俾同學聽。即係大家嘅答案咧好似唔同，但係咧即係嗰個 equation 嘅做法過程裏邊咧都係一樣嘅。
咁
即係。
而家你俾我嗰份 table integration 咧，係咪已經包含晒所有嘅 table integration，定係淨係部分咧？因為有啲簡單啲嘅 integration 我係睇唔到有咯。
唔係㗎，有㗎，有晒㗎啦。嗱，有兩份嘅，一個 formula 書，一方面咧就 formula for derivative 嘅，有晒。有一個咧有一個 page 嘅，一個咧就有我唔記得咗5至6個 page 嘅。你睇晒佢係包括晒你第一個 course 咧學420即 calculus 嗰科咧，你應該係知道。即係其實有啲同學你學過 M1、M2 咧，其實 calculus 咧第一個420咧已經係知道晒。你直情可以上嚟呢個 course 咁滯㗎啦。咁但係個問題咧就而家就學過 ordinary differential equation 咧，就會有啲 first order、second order、high order 同埋 partial differential equation 咧。咁你有少少唔同嘅但係
因為即係 VNQ，我之前係讀 Ivy 過嚟嘅，我之前咧 Ivy 嗰份咧係好似唔止咁少 integration 嘅嘅嘅識㗎，但我真係喺你嗰份咧 equation sheet，我唔係講 diver
係即係個
份我係
derivative
講
嗰度係
揾唔到有適合嘅識去用喺 example two 嗰度咯。問題
嗰度咧就係用到 basic 嘅 technique 就冇咩特別。喺 example two 裏邊冇咩特別嘢嘅啫喎，只不過話俾你聽介紹咩叫 ODE 咁解啫喎。所以你做普通嘅 integration 嘅方法就做到㗎啦。
但我想問呢度佢需要用嗰個 integration 方法咧，係咪任喺 table integration 或者係你派嘅 notes 入面，其他 notes 入面列出嚟咧呢一樣嘢？
有㗎，有頭先我 formula sheet 裏邊有㗎嗱，或者我睇下幾時，如果你有時咧就翻過嚟嘅時候咧，我解釋俾你聽。因為點解咧？做嘅時候咧會有第一頭先講幾種方法，第二咧就係每一種嘅 equation 咧之前係已經喺個 table 裏邊有，或者 suppose 咧你應該 calculus 嗰科咧就學過嘅。如果未學過嘅話咧，咁你會有啲唔同嘅 idea，或者我哋都可以 brainstorm，到時咧你可以同我講解翻下，咁我哋會話翻俾你聽，即係嗰個步驟啊，或者邊度揾到一啲嘢，好冇？或者我哋繼續先啦，好嘛？OK，唔好意思Thank you. So because we have some students ask some questions regarding to the differential equations and the number of examples related to previous example 1, 2, and 3. Okay. Of course, we understand there are different types of way to solve the solution, and most importantly will be the formula largely given by the formula sheet. I put it already on the Moodle. That is the formula sheet and also the formula for derivative. Okay. So in any cases, if you have any problem, you cannot find the equation, the correct or right equation, please come approach to me directly, and I'll give you some more or refer to some material to you. Okay. Sorry for the interruption. Right. Okay, we go ahead now for differential equations. Now we come up to the example for exponential functions. Then we have the new one called the separable ODE. Okay, for the separable ODE, we have a function like this. Okay, you have a combined function y dash x. Okay, so our method is to try to single out the items at both sides, and also left with all on right hand side except the y on the left, or y at one side. Okay, not that necessary on the left hand side. Okay, so long as you left the only y on either side. Okay, left or right hand side, and put everything on the other side, then we'll be fine. For example, if you have the continuous functions like this, and then constants will come out, so you should be added after integration. By referring to the separable ODE, we have the example in here, example 4. So for example, to mixing some problems. Now we are talking about a magic tank, the water tank. Okay, it is in the chemical plant, the chemical industry. We are trying to explain how it can solve the basic problem involving a single tank, in which the tank in these figures is so there are 1,000 gallons of water, which is initially 100 pounds of salt will be dissolved. So this tank will run in the rate of 10 gallons per minute. And each gallon contains 5 pounds of dissolved salt. So the mixture in the tank will be kept uniform when we are stirring it. Okay, so this tank runs out at 10 gallons per minute. So what is the amount of salt in the tank at any time t? So this is a normal general daily life situations that we have to come across, and we try to find out the mathematical formula. So this is kind of an example for separable ODE. So let's put some variable at the beginning. Usually this kind of water running or hydrology will be related to time. So let's suppose the equation y bracket t. Bracket t, that means we'll refer to the time, and the amount of salt will be in the tank. So we left y function t will be the amount of salt in tank. Then if we are doing the derivative, that means we are counting on any single time, then how much salt will be running. So the salt inflow, that means the income, and the salt outflow, outgoing. Okay, the difference of them will be the y dash. Okay, so we are having the derivative functions idea. Now it's the blue in color, actually explaining for the statement in the questions here, right? So interpret in some mathematical model or form that's become here like this. And then you have the salt inflow, where you have the salt inflow is where because you have 5 times 10 gallons per minute, because you are going to dissolve the 5 pounds of salt into the water at the rate of running at 10 gallons per minute. So you 5 times 10. So that is the salt inflow to match with this blue color. And then you have the yellow one. The yellow one will be the salt outflow, where we have 10 gallons of mixture come out from each minute, and altogether you have 1,000. So 10 over 1,000 is y, is sort outflow. So after we simplify or put together two equations, you will end up with this. Y dash equal to 50 minus 0.01 y. So that is the, again, you look at the IVP, initial value problem. Initial value will be 100 pounds of salt. So 100 pounds of salt will be starting with initial value when the time is 0. The time set is 0. And then you have 100 pounds of salt being dissolved. So that is the IVP. So by interpret the whole questions or statements, you become the example 4, where you end up with two equations. One is a general equation, ordinary differential equations. The other one is initial value problem. So what we try to do is try to find out, as instructed earlier on, single out the problems, and then we end up with the equation where you have y on one side and everything on the other side. Okay, so how we do that? Dy over dx, first of all, you have to solve the y. So by moving term, okay, by moving terms and put the products into the denominator and end up with left-hand side with y, and everything on the right-hand side is a constant. Then we integrate both sides with respect to time, t, dt. 嗱咁開頭咧，我哋就將頭先嘅題目就係話講喺一個廳裏邊咧嘅 mixture，根據佢個水流速度咧，我哋用咗啲鹽嘅鹽液落去。咁佢呢啲嗰個所謂 y dash 咧就係個 rate of change，咁就係嗰個 salt inflow 減 salt outflow。咁咧我哋就 end up with 咗一個 equation 呢一個嚇頭先。咁然後咧，我哋有 initial value 開始嘅數值，就係當佢0嘅時候咧，我哋100磅嘅鹽咧係會用咗喺裏邊嘅。咁所以咧，我哋就將個 equation 咧，首先解決咗左手邊嘅 equation。嗱，左手邊嘅 equation 咧，我哋就將佢簡化咗之後咧嚇，咁將佢將一 b 屬於係 y 嘅擺埋一邊嚇，另外嘅 constant 咧就擺另外一邊。另外咧就兩邊咧做 integration， 相對於個 time t， 即係 respect to t。Now then we change on the left hand side. We try to integrate it properly because it refers to t. Somehow this is y dash and dt. You can simply by lot more understanding, y dash original equal to dy over dx. So you can just simply replace dy to stand for dt multiplied by y dash。嗱呢個咧就好似簡單嘅代數咁樣啦嚇。咁因為 dy over dt 咧就係等於 y dash。OK， 咁你 moving term 之後咧 dy 等於咩咧？咪就係 y dash 乘 dt 咯嚇。咁你將個 dt 乘過對面啫嘛嚇。咁即係呢個就係 dy。咁用呢個方法咧，你就可以 change variable 啦。咁 change variable 之後咧，跟住咧我哋出嚟咧就將佢轉咗做呢一個東西啦。咁我哋咧就相同嘅 variable， 咁我哋咧就好容易將佢就變咗做 natural log 呢個做法。亦都係啦。咁有啲同學咧就可能會有其他嘅方法咧去解決呢一個步伐嘅。但係點都好啦，你最後咧就出嚟咧個數式咧會係差唔多一樣噶啦嚇。咁呢度咧我哋就做咗 natural log 因為 integrate 一個1 over y 得dy 咧就係 natural log y 咁樣嘅嚇。咁呢個 variable 喺裏邊。咁然後咧就加個 constant。咁亦都右手邊咧又係一個 constant integrate 嘅話咧就加個 t 喺度啊。咁我哋咧將佢亦都係啦，揾一個 C3 去代替咗 C1、C2 啦，就 constant 嚟嘅啫，冇所謂嚇。咁其他咧，我哋就將佢簡化成為咁嘅式。咁再將佢咧by index rule 咧 我哋將呢個 natural log 擺喺呢度就變咗 e 個 exponential 呢一個公式，將嗰個式咧就保留翻。咁呢個咧就已經係一個有個 constant。咁啊 constant 咧就呢個 C3 咧 e to the power of C3 咧你可以揾個 C 去代替佢就得㗎啦。咁啊所以呢個 index rule 咧就係變咗 e to the power of minus 0.01嘅 t。嗱咁呢個咧就係一個 general solution 啦。咁然後跟住咧，我而家做第一 part 啫。咁第二 part 咧，咁呢個就係我第二個要做嘅啦，就係因為 all y at one side and all x with other information 咧就 on the other side。咁我哋已經差唔多做完㗎啦。即係當然睇唔到嘅話咧，我唔緊要，你將一個減5000咧加翻右邊5000一樣嘅啫。總之個 equation 有一個 y 出現咧就搞掂㗎啦。好啦，咁個 y value 之後咧，跟住我哋而家擺個 y 0 100咁啊將個 t 咧係0，y 就係100，咁啊將擺落去嘅話咧，咁我哋 solution 揾出嚟咧個 c 咧就係-4900。咁呢個咧就係我哋藍色嘅 particular solution 啦。咁呢個咧就係 separate ODE 嘅做法，將頭先我哋呢個 example 4咧有一個現實生活嘅嗰個例子咧轉咗一個 mathematical model，咁然後咧得咗一個 general solution 同埋一個 particular solution。Example 5. This is the explicit solution of the equation like this, right? Now, in this equation, we try to do the more or less the same method to single item at both sides. Then, by moving term, we have all y on one side and all x on the other. And then we try to do the integration. Take integration on both sides, right? And then you change the value, integrate with 1 over y squared plus 1 will be the arctangent, okay, according to the formula. So you always refer to the formula when you revise this piece of looks. One thing I would like to draw your attention that for go through the lectures, I'm recording it, so I will later put it into YouTube or whatever into the Moodle so that you can always revise it. But of course, not every lectures. But for the first lecture, I would like to do that because there may be some students who are doing the ad job and they don't know the course requirement of this course. So I would like to recording the first lectures. Then occasionally, some lectures may not be recorded and put it on the Moodle later on. So don't rely on every lecture or put it on Moodle. Only in these first lectures, I'll put the videotape on the Moodle. Okay, probably I'll put the YouTube link onto the Moodle so that everyone can do the revisions. By doing the revision, please understand by yourself, by go through all those formula, derivative integration formulas that I put it already on the Moodle. OK， 嗱，即係温書嗰度咧，我重翻中文講多次啦嚇，我會將今堂嘅嘢咧就錄起咗，你見到大家見到㗎啦，錄起咗嘅。咁我會擺翻落去嗰個 Moodle 嗰度，但係咧我就唔係堂堂都錄嘅。如果唔係堂堂都錄嘅話咧，你又唔使上堂啦嚇。咁變咗咧，我哋就會盡量啦，因為第一堂咧我一定會錄，因為點解咧？有啲同學咧 at job 嘅時候咧就未加入嚟嘅，咁所以佢睇翻嘅時候就方便啲嘅啫。同埋第二樣嘢咧就係話當你温嘅時候咧，麻煩你睇翻我喺 Moodle 嗰度俾啲 formula 你，嗰啲 formula 咧當然係只係得 formula 啫。如果你嘅 calculus 咧之前咧學得好啲嘅話，你就會明白點樣用。但係學得唔好嘅話咧，咁當然啦，我 tutorial 都會再重新復述一下，或者係點樣做法去補救下。咁否則嘅話咧，睇個 formula 你先知道我頭先做嗰啲嘢點解會轉得咁快。咁有啲同學可能轉快，有啲同學可能識嘅話咧，覺得我轉得慢嘅。咁總之取個 balance 咧，大家都明白即係學嗰課嘅時候咧，我都統一。因為180幾人嘅話咧，我冇可能咧就個個都跟嗰個程度講得快啲或者慢啲，我只能夠係中庸之道嘅啫OK 嗱，咁所以咧呢度咧亦都係即係解釋俾你聽啦嗱，你可以温翻轉頭嘅，但係你一定要對嗰個方面要熟悉先得好啦，咁呢度咧就係頭先啱啱講嘅，就係譬如話1 over y square 加1咧 呢個 integration 嘅時候咧係個 attention 嚟嘅。咁你自己可以睇翻 formula sheet 裏邊有個咁嘅式嘅，即係 derivative of attention 咧係等於1 over y square plus 1，所以 integrate 嘅話咧就等於調翻轉啦嚇。咁所以呢個咧就係唔係我轉得快，而係個 formula 本身係有嘅。OK。So just remember you have to cross-check after I put the video tape on the first lecture. Only on the first lecture I put it on the Moodle. Okay. When you do the revisions, try to understand all your formula that I put it on the Moodle already. So make sure you understand it. If not, you have to revise it by yourself, or you can come across to your tutor to ask for more details. Okay, of course, tutor will be different. For EEM student, you have a tutor, Edward Chen as your tutor, and also you have Daisy Wong as your tutor. You have Yuan NG as your tutor. Okay, and also a tutor for some other group as well. Okay. Now integration for this again is reciprocal of x plus 1, so natural log x plus 1. And then this is the equations. It is understand that in your formula sheet. So after that, you can then write down the arctangent. This format is called the arctangent. Arctangent. 中文唔知點譯啊。總之喺個右上角中間度有個符號負1，咁咪叫 arctangent。So arctangent y equal to natural log x plus 1 equals c. So y simply because of the reverse sign, you simply put y as the variable on one side. So you left everything on the right hand side. So you have the tangent, arctangent. Move to the right hand side, become tangent. So tangent 呢個 function 咧就係。So you have to practice other things to find the solutions. Okay. For example, in these questions you have another examples. So for this mathematical form, try to single items at both sides. You have all y on one side and x on the other. So single item at both sides. So you change from there to that form. And then all y on one side, and now you understand you have another steps to taken. That is to take the integrations. The integration of everything with respect to dx. Again, y dash dx equal to what? Y. dy. Okay? Yes, dy. So dy, then y dash dx, you become the dy on the left hand side. Okay, so y squared. And then integrate of this will become the things like the constant. You have 1 over n. So that means 1 over the constant 2. So 1 over 2. And then integrate this, in the derivative of this, you have 2x minus 1. Okay. So change of variable happen here. Another format is having the integrations. That is y2. That means y integrate with the index -2. So when you integrate, you plus 1. So you got 1 over y minus. Okay. So that means y minus 1 at the end. So -1 is a reciprocal of y. And that's why it becomes -1 over y. And then you have a left of constant after integrations, C1 and C2. Okay. And then you have the big constant. Replace the C1 and C2. And then you have the reciprocal of negative. Then your negative and the reciprocal. So whenever you have the reciprocal, you try to put a format so that it is easier or nice looking. And then before you upside down for having the y only on the left hand side. So that is the step for treating the explicit functions where you have separable ODE. Okay, so they have y, x, they have a derivative of y. So end up with y equal to something. So for the separable of ODE, what we try to do is try to do it by substitutions. Try to reduce the ODU to separate form by substitutions. So for example, this new questions, y dash equal to x plus y complete square. So you try to single item at both sides, and then you have all y on one side and x on the other. But that is not true. You can't do that because you can only do it by substitutions because they are complete square. So in this way, how are you going to do it? Now look at these examples. Just recall your memory. If you have people who do well in Hong Kong DSG, the M1, M2, or you do it well in the calculus, you should remember, you should hardly remember that there is a method called substitution. So just simply substitute with some variable for anything who are under square bracket. Okay, the square bracket here. So you take a variable, for example, u, or anything v, or even z. Okay, okay, you have the u replaced by x plus 1. Okay, so after that, you change every variable except y. Except y. So you have the dy over dx. So you change your variable, you dy over dx. Okay, and then 1 plus dy over dx. So you have understand if you derivative of this function, you have dy over dx, that is dx over dx, so yes 1, dy over dx, that is this. Okay, so you just straight ahead doing derivative, and then you have the symbolic form du over dx, like dy over dx, usually have a dash on the right hand side. So you have du over dx is equal to u dash. On the right hand side, you have 1 plus, that is same meaning, y dash instead of dy over dx. That is usual notation for having derivative. Okay, and then after that, you do the moving term. Moving term. You try to put the y on one hand side. So complete the substitutions. Sorry. You then go to substitute the original value. Okay. I mean the original equation here. You have the y dash minus 1 here. Okay. So y dash minus 1 replace y dash on the right hand side. That is u2. Sorry, u. U dash, that means you carry on doing the normal things, moving everything u on one hand side. And then combine two together. You are integrating both sides. Integrating both sides, you have a simple format. So you come up with the arctangent again with constant on the left hand side and the variable x on the right hand side with another constant. So you have another big constant replacing the two small constants. So arctangent y, arctangent u, can put it in this way. You put it on the right hand side, you become the tangent instead of arctangent on the right hand side. So after that, that is the n, right? The u equal to tangent bracket x plus c. but it's not n yet because you use the method of substitutions. Somehow you have to replacing back x plus y into u. Okay, so you have x plus y replace u, and then at the end you change it back and moving everything except y to the right hand side. So you left y and minus x. So that is the answer, and that is the way of using method of substitution to solve your answer. So that is the way how you handle it. So in this case, by substitution, you have to remember all the time to replace back your original x and y function to your substituted variables. Okay, so by means of the substitution, you can then simply solve this problem. Right. So that is something that we are related to. So just look more, one more examples. Okay. So for example, this mathematical model, again, you use the method of substitutions. For substitutions, it is y equal to ux. Okay, y equal to ux. So you can understand that there are derivative of two variables. Again, there is a formula, x du over dx plus u over dx. So that is the differentiation of two variables. So by having such substitutions, you can simplify the form in this way by having the u. Then you can put it back to your way that how it is going, right? So you have x, y, or y dash. So y dash, you have to y dash replaced by 1 plus y over x. So you just simply replacing your functions into the suitable change of variables after the integration on the left-hand side. You simplify this as this, right? And then you put it back onto your equations so that everything can be replaced by u instead of y at this moment. So later on, after your moving term simplifications, you're left with a simple format. Then you have left the x on one side, so you put it back on by separating the variables. Okay, you just left with u, and after that you have to double or integration on both sides. After integration on both sides, you can change it to change of variable. As I recall that the u dash is equal to du over dx. Okay, so du can replace u dash dx. So you change of du. Then after that, you have the simplified form left with the u on one side and x on the other. So then you integrate it. You left with some constant. Left hand side u, right hand side is natural log x. So you just simplify it as constant, general constant c. You on left hand side, you just left with the u. Now that is the part of the solution. After that, you just remember your substitution. Your substitution will be y over x. Then it is just simple. So exact ODE come out, okay? After you insert the y. So that is the n. You can just end up with here today. Please revise the rest of the PowerPoint at these notes So there are a few more examples. You can just do it, and then maybe we can then recall some formula, okay, or the partial derivative, okay. For some partial derivative, whenever we do it, we just emphasize on whenever you have derivative with respect to certain values, you just ignore all the other variables at the time. You treat it as constant. So we call it partial derivative. And also the partial derivative, we have the symbol like this. Not the d, but the partial derivative symbol. It is different from d. Okay, you can see this symbol like this, right? I write it in this way. Okay, so this partial derivative is like this. So this is some kind of equation. Try to prove it to you, the mn equations. So it end up with the equation u and u where you have m and n equations. So maybe we end up here first, so you can take some time to revise and do some more exercise, or you are preparing yourself to try to look for some books which are suitable for our engineering mathematics. I already put those name of the books for engineering mathematics into your TLP. So please check of your teaching learning program outcomes to make sure yourself can understand the basic integration and differential equations, and then go to advanced engineering mathematics. We all the time talking about ODE, and your basic differential equation or integration equations will be the foundation to this course. Okay, so maybe that is the end of today's class. I will put today's class into the video and then upload as the first lectures onto the Moodle. Okay. Now I take the attendance again. Okay. So we have 136 students attending the class today. Right. Do you have any questions? Yeah, I see some questions. The solution of page 31 PDF is missing. Okay. Yes, because the PDF version cannot display everything as I showed on the PowerPoint. But as you go through it, and then you may understand how it arrived with the solution that I do a step by step. Yes, certainly. For some students, ask me to show it again and upload the new PDF. Yeah, I try to do that, right? Okay. So if there's no more question, that will be the end of the classes today. Thank you all for your attention. So if you have any questions, just remember this week there will be no tutorial until next week. OK， 嗱，今個禮拜咧，我哋係冇 tutorials 嘅。下個禮拜咧，咁我哋有 tutorials 咧，就未必係我有時譬如話舉例 EEM 嘅同學咧，你嘅 tutorial class 咧就會係adversary 嘅。咁我哋 CE 嗰度咧就可能係有時有啲班別係我。有時係 Daisy， 有時係阿 Ewan 咁樣嘅。咁我哋喺唔同嘅 tutorial workshop 嗰度，咁我哋有啲 workshop 咧，我哋就會介紹嗰個 software Mathematica 嘅。咁嗰個 Mathematica 咧就會係幫你計啲數咧，咁你可以 check 翻嗰啲 detail 嘅 step 嘅。咁嗰個 Mathematica 個 software 咧就喺電腦室7樓嘅電腦室即係 DI 青衣 building 嘅7樓。OK， 咁佢先有 software 嘅。喺10樓咧，譬如話喺個 CE Lab 嗰啲係有電腦室，不過咧就冇呢個 software。好，咁係咁多。OK， 咁冇乜特別嘢嘅話咧，即今日就係完㗎啦。咁我就會將個 video 咧就擺翻個 video link for 呢個 first lecture。但係記住咧，我哋唔會係每堂都擺嘅，如果唔係大家又消失咗㗎啦。OK，好多謝大家，thank you。So see you next time. Same channels and same time, right? Thank you very much.